Good afternoon, class. My name is Miss Johnson, and today we are going to learn how to tell if a game is fair by using probability. So the first thing that we're going to do for today's lesson is go over our vocabulary word, which is fair game. We have it written here on the board already. And our definition for this is a game is fair if the probable winnings are at least equal to the cost of playing a game. So that's going to be our only vocabulary word for today. The next thing that we're going to do is we're going to go over our steps. We actually have two sets of steps. The first is the math steps, and the second is the steps for playing the game, which we will need to do in order to actually determine if the game is fair or not. Now, each of you have already been passed out a copy of both of these sets, so you can go ahead and follow along with me, and we'll go over them together. The first one for our math steps is to find out how much it costs to play the game. Now this one's easy. For this one, all you have to do is look at the word problem and it will tell you how much it costs to play the game one time. The second one is to determine the probability of landing on each space of the spinner by looking at the spinner and determining what fraction of the spinner each space is representing. So we'll do a couple examples up here together so you can see what I mean. So we have 3 spinners. Okay, so if we have the first spinner, it has a space for a 1 and a space for a 2. Now if we look, this is 1/2 of the spinner, and this is 1/2 of the spinner. So you have a 1 in 2 chance of landing on the 1, and a 1 in 2 chance of landing on the 2, which is 1/2 for each one. Now this one, this is 1/4, 1/4, 1/4, and 1/4. So for each of these you have a 1 in 4 chance, which is 1/4, of landing on the spinner. Now for this one, we have the fourths, but we also have these smaller spaces. If we were to divide all of our spaces into that size and count them, 2, 3, 4, 5, 6, 7, 8, there's 8. So each of these represents 1/8, and then these are all 1/4. And those are the different fractions that we'll have in our practice problems today that you guys will need to know. And then this just tells you how to determine which one it is. Does anybody have any questions? No questions? Okay. Now next we're going to go over the steps on how we're going to actually play the game. Okay, so to play the game, the first step is to determine the cost of playing the game one time. We already know how to do that from our math steps. Step 2 is to determine the probability of landing on each space. We also know how to do that from our math steps as well. Step 3 is going to be to use these paper squares, which are pre-made for you, and I will pass them out to your groups during practice time. You'll use these as well as your basket. You'll put the squares in the basket, you'll mix them up, and then you'll draw out a square 10 times to determine what this is representing the spinner. So for each time, say you draw a 1, you'll record that, and then you'll put it back. You'll draw it again. Say you draw a 3, you'll record that. You'll do it 10 times. When we do these problems on the board, I've already drawn out for each problem and recorded my results. So I'll go ahead and just write them up here for you. But when you do it in your groups, you guys will go ahead and draw them out of the basket. Now, after you've recorded your results for 10 times of playing the game, you will determine how much it costs to play that game 10 times. We also know how to do this from our math steps. We're going to multiply the cost of playing one time by the number 10. Very simple. The next step is to determine what it would cost, or what your probable winnings are after 10 times. So you'll take your results that we'll have and you'll add them all up. Then you will compare them together. If they're at least equal, then you will know the game is fair. If they are not at least equal, then you'll know the game is not fair. Now we'll do 3 problems, and then you guys will do your group work. So your first problem is: the school is having a carnival to raise money. In the following game, the player spins the spinner and receives the dollar amount of the spinner the arrow lands on. It costs $1 to play this game. Is this game fair? So we know step 1 is: how much does it cost to play one time? It costs $1. We saw that from our word problem. Step 2 is to look at our spinner and determine the probability. So I will draw your spinner up here. Okay, so we have 0, 1, 2, and 3. So those are the numbers we're going to want to determine the probability for. We can see that the 0 is split into 1/4, but together they take up 1/2. So it's going to be 1/2, which is a 1 in 2 chance. The 1 is 1 in 4, it's a quarter, and the 2 and the 3 are both eighths. Anybody have any questions? Okay, so now that we've done this, we'll use our squares, we'll put them in the basket, and we'll draw out 10 times in order to determine our probable winnings. Now, in order to save time, I already did this earlier and I recorded my results. So I will go ahead and write those up here for you. We had 0, 1, 1, 0, 2, 0, 3, 1, 0, and 2. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Now, if we add this together, we have 1 and 1 is 2, plus another 2 is 4, plus 3 is 5, plus 1 is 6, plus 2 is 8. And then also we need to determine how much it's going to cost to play 10 times. Now we remember how to do this. The cost of 1, which is $1, times 10, it's going to be $10 in order to play this game 10 times. Now, to see if the game is fair, we need to see if this number is at least equal to this number. 8 is less than 10, so in this case the game is not considered fair. Does anybody have any questions? Okay, so now we're going to do practice problem number 2, which I'll go ahead and read to you. A school is having a carnival to raise money. In the following game, the player spins the spinner and receives the dollar amount of the number the arrow lands on. It costs $2 to play this game. Is this a fair game? So our first step is to determine the cost of playing the game one time. We know from our word problem that it's going to cost $2 to play the game one time. Our next step is to look at our spinner and determine the probability of landing on each space. Okay, so if we look at our spinner, we see we have a 0, 1, 2, 3, and 4. So these are the numbers that we are going to determine the probability of landing on. If we look at the 0, it takes up 1/4. If we look at the 1, it's also 1/4. The 2 is split into eighths, but because together it takes up 1/4, that's going to be the probability. And then the 3 and the 4 are both 1/8. Does anybody have any questions so far? Okay, so next thing we're going to do is we are going to play the game 10 times and write down our results so that we can see if the game is fair. Now, as I mentioned in problem 1, in order to save time, I already went ahead and used the squares to draw 10 times and recorded my results. So we have 0, 3, 1, 0, 2, 4, 1, 2, 0, and 1. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times that we did that. Now we're going to add these up. So we have 3 plus 1 is 4, plus 2 is 6, 4 is 10, plus 1 is 11, plus 2 is 13, plus 1 is 14. Now we want to determine the cost of playing the game 10 times. In order to do that, we're going to multiply the cost of playing one time by 10. So we know from our previous step that it's $2 to play one time. So 2 times 10 is 20. So 14 is less than 20. Since they're not at least equal, we know that this is not a fair game. Now we're going to do one more practice problem so that we can just make sure that you all got the hang of it. And then we will go ahead and get into our groups to work on some problems together. So problem 3 states that a school is having a carnival to raise money. In the following game, the player spins the spinner and receives the dollar amount of the number the arrow lands on. It costs $3 to play this game. So step 1 is how much does it cost to play the game? We know from our word problem it costs $3. Step 2 is to look at the spinner and determine the probability of landing on each space. So if we look at our spinner, we have 0, 2, 3, and 4. These are the numbers we're going to determine the probability of landing on. And this one is pretty easy. We can clearly see that each one takes up 1/4 of the spinner. So you're going to have a 1 in 4 chance of landing on any of these numbers. And we'll write that as the fraction 1/4. Does anybody have any questions so far? Alright, the next thing that we're going to do is go ahead and play the game 10 times to keep track of our results. And once again, I already went ahead and did this earlier, and I did write down the results, so we can go ahead and write those on the board now. We do have 3, 2, 0, 4, 2, 3, 0, 2, 4, and 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our next step is to add these together. So we have 3 plus 2 is 5, plus 0, plus 4 is 9, plus 2 is 11, plus 3 is 14, plus 2 is 16, plus 4 is 20, plus 3 is 23. So we have a probable chance of winning $23 if we play this game 10 times. Now we have to determine how much it costs to play 10 times. So we'll take 3, the price of one game, multiply it by 10, which will give us 30. When we compare these, we can see that 23 is less than 30, so because of this, this is going to be an unfair game. Does anybody have any questions? Okay, so it looks like nobody has any questions, so we're going to go ahead and get into groups so we can do our practice problems. Since you guys are already sitting at tables, go ahead and work with the people you're sitting with. You will all receive squares pre-made and your baskets to draw out of. You will also receive the practice problems on a worksheet with worksheets for you to individually fill in the answers. After about 10 minutes, we will discuss, okay? Okay, so now that we've had 10 minutes to work on these, let's go ahead and just do a discussion to see what results y'all came up with. Do I have a volunteer for problem 1? Okay, Susie, thank you. So Susie stated that her group determined it would cost $10 to play the game 10 times. They also had a probable chance of winning $8, so they determined this was an unfair game. Very good. Now, how about for problem 2? Okay, Tommy, thank you. Okay, so Tommy stated that his group determined it would cost $20 to play the game 10 times, and that they had a probable chance of only winning $15, so they decided it was an unfair game. Thank you so much. Okay, one last volunteer for problem 3. Jacob, thank you. Okay, Jacob stated that it would cost $30 to play the game 10 times, and their group had a probable chance of winning $25, so they determined that it was an unfair game. Very good. As I was walking around, you guys seemed to be doing very good. It didn't look like anybody had any questions, so I'm going to go ahead and assign a homework worksheet, which will have 2 similar problems for you to do tonight. Go ahead and turn those in the morning for a grade. And that's going to be the end of our lesson today. Today we learned how to tell if a game is fair by using probability.